Most agentic production system break in 6 months because of the same reason. Someone in the team decided or think that agents are magic, and it's basically make a situation where agents break in production in 30,000 different way, right? So welcome. This is the first episode of Agentic System Design. We will first talk about agents and what agents are, and definitely like agents are not magic, right? So these agents words are thrown very loosely. Everyone is building agents. Every programs we are doing is calling agents. So before we go with actual system design, it is required to understand what agents are, right? So if we see, we are chasing this for 60 years. This is not very new. We always wanted a system or machine that's not only just answer but actually do something, right? So before to understand the agent better, let's go back into history and see like how these systems are coming, right? So if you see from ELIZA, so in 1966, it was like first computer program, which first computer chat bot, I will say, which was used for chatting, and we have achieved in 1966. People are surprised. It was used for psychological chatting with the people. And then if you see going further, we went to Deep Blue. Like it came in 1997. It was like in computers, which actually beats a human chess champion grandmaster in 1997. At that time, we are not able to talk to it, but it has logic. It was a little bit hype, but not much. But it was also one of the pioneer movement where we see that machine intelligence for the first time. And then moving forward, if we go in 2011, Siri launch, and it was like game changing. You can talk to the Siri, you can ask and do certain tasks, but Siri was also like kind of scripted. The good thing was like it's now we got AI in everyone's pocket. It's in mobile, so it's feel amazing. Although it was scripted, it can do certain tasks which was like already programmed. Obviously, Siri was not going to write you code or essay, but it can do certain jobs pretty well. And now, if we move forward to our timeline, this is the first time in 2022 when ChatGPT came, and that was the first general purpose intelligence came, where you can ask like any questions to it. It can form answers, it can respond, and it was not like scripted. You can just ask in the runtime, and it can respond. So that was the game changing for this AI race, and everyone start feeling wow, and then things started. And going forward, ChatGPT was still very good in like talking. It can generating text. It can give you responses, maybe like voice, but it was still not able to do anything. So going forward, like in 2024, like the Claude code came. So I will say with Claude code, like there are much more tools came like Devin, Copilot, basically LLM with tools. So now LLM become more powerful, where they can do something. They can run a command. They can do something for you. They can basically fetch things. They can make impact in real life. So this was like in brief history how this things can come to the way we have right now, right? So now the thing is like why now, like not 5 years ago, like when we have LLM from like 1966 we are trying, then why now, what changed, right? So there are basically three things which lined up perfectly, which basically cause what we are seeing right now, right? So first thing is a building block that can reason in natural language about like almost any problem. So I'm talking about the LLM become advanced, and obviously they become more perfect, where they can really talk about any situations, and they are like trained on a very well data. And the next thing is a standard way to give it tool. So when Anthropic launched MCP protocols, so now we have a standard way, like what is the input format look like, what is the output format look like, what is the protocol. So a standard and easy way. So now people start building tools, start exposing their system to the LLM, which LLM can use. So now suddenly like you see a lot of improvement in this AI era, where we are making agents or system which is actually doing something for you. So that was one of the game changing part. And the next thing is, which is very important, compute. So compute was very costly, but these days like compute is cheap enough that you can run this loop like getting something, thinking, output, and again doing it back to back in production. And even like you can run it on your laptops, like we have so much high like compute available these days, right? So if you see, like if you put all these three things together, you get something which actually do work, right? So that's what we are going ahead toward, like some agentic system which actually do something, right? So now we are refraining, like agents are not magic, right? Treating them magic is something which will give us into trouble. So agents are not magic. That is the one part which I want to clarify through the first video. And then, so if you see the naive view, like a general public view, what they feel like, LLM is something you just give the response, like you give the request and you do something and give you the result, right? This mental model is very simple. It is like good working, simple, but this is like something which is wrong, right? For a general public it's fine, but as an engineer, when we are building agentic system into the production, this mental model is something which can get us trouble, get us page at 3 a.m. because the LLM decided to delete a database, or it decided to just send thousands empty email to someone, or it can do something worse, right? So this is the mental model which can get into trouble. So we need to sift from this mental model. So now if you see what LLM or what agentic system actually are, so it's not just like simply magic things. So we will see actually what's there available in the system. So first, the LLM. So obviously the large language model which actually decide what the next token are. So this is the core part of this whole system. And the funny thing is, like this is sometimes can go wrong. It can go wrong very confidently, and this is like a undeterministic. So if you're giving a same input, there is no guarantee that you will get the same output, right? So what we can say, like this is a unreliable component. So you can't kind of rely on it because it's change its output every time. So this is like just one part of it. This is not like a whole system. Next thing is tools. So this is also this is like the functions which LLM can call, right? So for example, LLM right now is doing web browsing, it's searching, it can accessing your local file, like if the Claude code is right, and run commands, and then it can schedule some timer, it can basically call some API, do something, read your tickets, or it is do bunch of things. So these are calls like tools. So we will focus on this whole like series a good amount of time here, like how to build tools, how like we can give LLM the hands so that it can do something. And the tools can be here, the real magic, it can be custom based on your requirements. So we will spend quite some time here to understanding and designing and developing the tools part of it, right? So next is memory. So this is very like important. So there is two type of memory, one is short term and one is long term. Short term is context. So if you see like LLM, what it do, you put some input, it process and give you output, that's all. But to make it sense, like it's not like you just give one time input and it's process and give you the result. No, you have to loop through the process. You have to sometimes it's give something, you give feedback and do it again. So you need to store, you need to know a lot of things around it. So which is also we call like context, right? Kind of short-term memory. So we need to also design that part. And also then come the long-term memory. So short-term memory is good like for one session, and next session when you go, it's forget what was the behind. So it was not very good if you're designing some consistent production level agentic system. You need to also remember history and learn from it. So memory is an important part. We will cover it into our next upcoming session. So let's move to the next part, which is like orchestrator. So this is like another layer. So if you see, think, act, and observe. So if you like ever work with like some automatic system like the Claude code or Copilots, you see like what it do is it's take your inputs, it's read your file, do processing, and then give you some output, and then say okay, it's not good, and then again try, and then for example you can it's run your unit test, it's break, and then again it's do something, and it's a break, and then do something and it fix. So this is some kind of orchestration you need, where what you are doing is you are thinking, you are taking, you are acting on it, observing it's working, not working, and you are basically looping through the same like the steps, right? So that orchestration is something which is important if you want a truly agentic system which works by itself, right? So that is the part how we'll do it it will also come under the system design part later, right? And then next is able harness. So your agent are doing something, but you don't know like whether it's work or not, whether like the output it is giving is correct or not, right? So you need some kind of system around it which actually evaluate the output of the agent, that whatever it is returning you is correct or not, right? Otherwise you are just going blind. You just build a system and you really don't know what it is doing, right? So you need to know, you need to build a system which can evaluate and which can make sure that whatever the output is coming, because remember, LLM is unreliable, you can't trust them, so you have to engineer around it so to make sense of things, right? So this is also very important if you want to make a really good level system, right? Next is observability. So one more thing, what happening is like if someone like complain that I got this output which was wrong, or I got mail, how will you know that, right? So you need to have like your traces, logs, metrics. So it can break in prod, right? But this is how you will find out like why it's break, and that's why you will improve it. So again, this is not something, if you see we are new, right? If you're in like working in corporate or have some experience, you know, like these all things we are doing from a long time. So we have a proper production system, we have a matrix, we have a system, we have alarm, right? It just now things are a little bit changed, and not in a traditional way where we are doing it from some web application or service, microservice. This is more about building the same pattern around a agentic system. So we all are like aware about it. It just we need to shift little bit our mental model toward it, right? Now the last but not least, safety layer. This is the most important thing. If you are working for a like project, this is most important thing, because LLM are like, if you see, there is a lot of breaking going, a lot of security risk coming, because if you just trust LLM blindly that okay, just give all the permission and do something, it is a disaster. So you need to understand like what is permissions, how to authorize the LLMs or your MCP servers, what is the input sanitization, approvals gate, and multiple other things, right? So we will going to cover at least 5 to 6 lecture on it, because I believe, and if you see Anthropic, like they also believe that and like anyone who's designing system, that security is the most important part. So you should not compromise your security of your product or your organization at any cost. So this is like one of the important sector we will also cover into our next section, right? So this is the mental shift I'm talking about. Rather than thinking about the agents like a magic, we will think agent as in a distributed system with a unreliable component. So whole agentic, if you see, like this is a crux of our whole agentic system design course. What we will do, we will just think agents as an unreliable component in a distributed system. The whole course is making that unreliable component, like controlling the unreliable component, so that our system as a whole is reliable and good and doing something, right? So this is the mental shift I'm like telling in the first episode, because this is where we will build our whole logic on, and this is what we need to think about. We should not think about that LLM is some kind of like magic thing, right? So let's move. So 3 words that will change like how you will build, right? So first is distributed. So this is important because when you design agentic system, this is not just one part. There are multiple parts, multiple things working together, and which make a system really good or reliable, right? So keep that into mind. And next is system. So when I say system, you heard about system design or a lot of things. System, what system means? It means like it is engineered, right? It's not random. So there will be certain guidelines, there will be certain protocols. We will have like a certain like input validations, output validation, certain standards, certain contracts. So there will be a proper system around it. Nothing will be like random. So we have to think it like in system. So next thing is unreliable component. So this is the one of the most important part. Do not trust LLM. I mean, it is probabilistic, right? It can go wrong. It can lie confidently with you. It's not about it's lying. It's just like it will give you a response whether it is accurate or not. They don't know, right? So we have to always think LLM as an unreliable component, that it can go wrong, and then we have to build things around it. So if we think like this mindset, our product will always be much better and secure, right? So let's move. So the 5 question, the rest of this course answer, which we will follow. The first is what can go wrong, and definitely how to catch it before it's go to prod. Next is like, how do I know if it is working or not? And next thing is how to control the blast radius, because things can go wrong, right? But we have to make sure that it's not impacting a lot of things. Blast radius, how to we can minimize. Next is like, how do I test it? This is most important like thing, because when we are developing something, right, when we are developing website, we know how to test it local. We can test our service local. So if we are like building an agentic system, right, how to test it local without actually burning the token, because that's very costly, right? So and then like how we'll actually deploy it, what is the CI/CD and all those things, we'll also cover that part. Next is like, how do I pay for it? That is like something. It should be some like predicted, some like known thing, right? It's not like we just go on sleep, next day we get a surprise bill. No. So there should be a limit on your budgets, and like how we'll manage it, how to put alarms there, because that is the affordability is the important part. Money matters, so we need to be frugal in that segment. So we will also cover that aspect into our design, right? So here's how we will get there. Upcoming courses will look like, we will cover like part 1. So part 1, which will be like a theoretical part, which is very important to know, like what LLM is, what is like chain of thought, what is like RAG things, how we'll give it knowledge it's not trained on, or how we'll give it the tools. So and we will build like a first real agent on a smaller scale. So that will be like the first part. Upcoming few episodes will look like this, and then next will be the actual core engineering, the real one. So we are going to build a AI digest. What it will do is it will automatically crawl new AI news, and then it will summarize it, it will rank it, and it will notify me on like Messenger or Telegrams, where I can review it, give feedbacks, and automatically publish on website. So we will do it in a proper way. There will be a proper failure modes, observability, orchestration, and also we'll do like a multi-stage deployment, like alpha, beta, gamma prod. We will also like explain that part, how what is the benefits and all, right? So the next question. So if you watched till here, thanks for the watching. Please do like, share, and subscribe. That will really motivate me for coming up with the new lectures. So see you there. Thank you. Bye.